Hello viewers, I'm Kausalya. Today we are going to discuss about the topics selectivity and half power frequencies and finally bandwidth. So here, this is the typical circuit diagram that represents resonant frequencies and currents. So here F0 is the resonant frequency. So at resonant frequency you can see the current is maximum, right? And the respective value of current at resonant frequency is denoted as I here. And the next two frequencies are F1 and F2, right? F1 is called lower half power frequency and F2 is called higher half power frequency. And the current at F1 is respectively I1 and the current at F2 is respectively I2. Okay, anyways, here both the currents are same, therefore I1 is equal to I2, right? Now, why we are calling these two frequencies, that is F1 and F2, as half power frequencies means, that is the power will be half of the power which is available at the resonant frequency, right? There will be some power at resonant frequency, right? For example, the power at resonant frequency be some 10 watts, right? Whereas the power at F1 and F2 will be equal to 5 watts, that is half of this power, right? Okay, these are all the things just I have quoted just for example. Okay, don't take it serious. For example, if we have power as 10 watt at resonant frequency means, then we will be having 5 watts power at half power frequencies. That is the reason why we are naming these frequencies as half power frequencies, right? So here again, by the definition of, you see, half power frequencies, so here half power frequency, right? So the value, that is I1 square R, is equal to I2 square R, which is equal to half of the power at resonant frequency. So what is the current here? Current at resonant frequency is I, therefore 1 by 2 into I square R here, right? So now, since we are having R in all the three terms, we can cancel them, and finally the value of I1 is equal to I2, and which is equal to 1 by square root of 2 into I, right? So at half power points 1 and 2, it is clear that, you see, the current is, that is 1 by root 2 is nothing but 0.707. So the current is 70.7% of the current at resonance, right? Am I making the concept clear? You see, at a particular frequency, the current is I1. At another frequency, the current, that is at frequency F1, the current is I1. At frequency F2, the current is I2. Right. So what is the formula for power? It is I square R. Therefore, at F1, here we are writing I1 square R. At F2, here we are writing I2 square R. So, which is equal to, their values are equal to half of the power during resonant time. So 1 by 2 into the current at resonant frequency is I. Therefore 1 by 2 into I square R, right? So here when you compare these three terms, R is a common thing, right? So we can take it out. So finally we are taking the square root also, right? So I1 square becomes I1, I2 square becomes I2, and here I square becomes I, and this 1 by 2 becomes 1 by root 2, right? So at half power points, that is what are all the half power points at points 1 and 2, it is clear, right? What happens to the current? The current is 70.7% of the current at resonance, right? Let impedance be the Z be the impedance at half power points, right? So I1 is equal to I2 as we all know, and what is the formula for current? It is nothing but E by Z, right? And again I1 and I2, so just now we have seen, right, this I1 and I2, that is equal to 1 by root 2 times of I, right? So you just write this 1 by root 2 here as such, and I can be rewritten as E by R, right? Because during resonance impedance is equal to R here, so we can write it as E by R. So when you compare these two equations, you see in the place of Z here we are having root 2 times of R, right? So that is the reason here why I had written like this. Z is equal to root 2 times of R, right? Then the next thing is cos pi. So cos pi is given as R by Z. So here the value of z is root 2 times of r. So just substitute the value here, and finally the power factor is calculated as 0.707. The next thing is at half power points, the power factor is 0.707, right? So, or we can simply say at an angle of 45 degree, we are having the power factor as 0.707. So, at F1, you see the power factor is leading, and at F2, the power factor is lagging, right? So, let z is equal to, that is root 2 into r. We have just now calculated it, right? So with the help of this expression, we are going to find some other new things. So squaring on both sides, that gives z square equal to 2r square. And what is the formula for z square? It is nothing but r square plus xl minus xc the whole square, which is equal to again 2r square. So here when you rearrange, you see xl minus xc whole square is equal to r square. So when you square on both sides, okay, when you take square root on both sides, xl minus xc becomes equal to r, right? So here this is our base formula. Now we are going to find the respective cutoff frequencies and bandwidth based upon this formula. So at lower half power frequency, what is the thing here? The value of xc is greater than xl, right? So when xc is greater than xl, what happens? R will be in negative. Can you get? You see xc is greater. For example, xc is 5 here and xl is 1 here. So 1 minus 5 will give you minus 4, right? So that is why here xl minus xc is equal to minus r. Right. So again substitute the values. So xl is omega 1l and xc is 1 by omega 1c. Again when you take LCM, you see omega 1 into L into omega 1 into C. So that gives omega 1 square LC minus 1 is equal to minus R omega 1 C. Again when you rearrange, we are having an equation like this. So here this is our expression. Again now we are going to find the value of roots. So what is the base formula? It is given as minus b plus or minus root of b square minus 4ac divided by 2a. Right. So here from this expression, this is your a, this is your b and this is your c, right? That is LC is your a, RC is your b and the value of c is minus 1. Right? So just substitute it here. After substituting, you see, yeah, this step has to be noted. Here the thing is, I am going to write this 2LC. I am going to split this 2LC for each and every terms here. So minus RC divided by 2LC. But when you look at these terms, all these terms are under a square root, right? So in order to move this term into the square root, you have to square it. So when you square, what happens? 4L square C square. So that is what I had written here. Plus again 4LC divided by, again when you bring this term inside the square root, you have to square it. So again 4L square C square. So when you cancel the common terms, finally we are ending up with the expression like this. Minus R by 2L plus or minus square root of R by 2L the whole square plus 1 by LC. Right. So let this be our equation number 1. Now the value of R by 2L is very less than 1 by LC. Therefore, we are neglecting this R by 2L. Right. So, this term we are neglecting. So, finally, our expression has omega 1 is equal to minus R by 2L plus root of 1 by LC. Right. So, the next thing is we are considering only the positive term. Okay. So omega 1 is 2 pi f1 and this term remains the same. So we need only f1. So f1, to find f1 we are moving this 2 pi to the right hand side. So 2 pi occupies the denominator part. Therefore this becomes minus r pi. 2 into 2 pi becomes 4 pi l plus 1 by 2 pi into root of LC. And 1 by 2 pi into root of LC, this is nothing but our f0. Okay. So just replace this term with f0 and finally f1 is given as f0 minus r by 4 pi l here. right? Now the next thing is we are moving to F2. So at F2 what happens? XL minus XC is equal to R, because here the value of XC is less than XL. So what happens? Automatically R becomes positive. So again just substitute the values. So omega 2L minus 1 by omega 2C is equal to R. So when you take LCM, what happens? Omega 2 square LC minus 1 is equal to R into omega 2C, right? Again when you rearrange, here we are having an expression like this. So again we are using the basic max formula, okay, to find the values. So here, okay, that is minus b plus or minus root of b square minus 4ac by 2a. Again we are moving this 2lc inside the square root. So we have to square these terms. So automatically 4l square c square. When you cancel the common terms, finally we are ending up with the equation like this. R by 2l plus root of R by 2l whole square plus 1 by lc. Again the value of R by 2l is very small when compared to 1 by lc. So here we are neglecting this. So our expression becomes omega 2 equal to R by 2l plus root of 1 by lc. So omega 2 is nothing but 2 pi f2. Therefore f2 is given as R by 4 pi L plus 1 by 2 pi into root of LC, right? So again F2 is nothing but, this is our F0, therefore F0 plus R by 4 pi L. Now we have calculated the values of F1 and F2 respectively. So what do you mean by bandwidth? Bandwidth is nothing but the range of frequencies between this F1 and F2. Therefore bandwidth is equal to, this is given as F2 minus F1. Okay, so just substitute the values of F2 and F1 here. Finally we are ending up with the answer as R by 2 pi L, right? So this is our bandwidth. Bandwidth is given by F2 minus F1, which is equal to R by 2 pi L, right? And again the sharpness of the tuning, okay, it depends upon the value of R by L. And again small value of R by L, if the value of R by L is small, then it is a sensitive system, right? The next thing is quality factor. So quality factor Q is given by F0 by F2 minus F1. So we know the value of F2 minus F1, right? It is nothing but R by 2 pi L. So just substitute the value here. And again, when you rearrange, you see we are getting an expression like this. 2 pi L F0 by R. So this is our quality factor Q. So again, when you rearrange, you see Q is given as omega naught L by R, because 2 pi F0 is nothing but our omega naught here, right? So this is omega naught L by R. This is in terms of an inductive circuit. In case of a capacitive circuit, again here the quality factor is given by 1 by omega CR, right? So again you see from the equations of omega 1 and omega 2, right? So here we are multiplying omega 1 into omega 2. So what happens here? You see, this is of the formula. Let us assume let this as your term A and this as your term B. So here it is A minus B and here it is A plus B, right? This is your A minus B and this is your A plus B. So what is the formula? A plus B into A minus B? It is nothing but, what is the answer? Here it gives A square minus B square, right? So this is your A, when you square it, A square minus, and this is your B, so it is B square. So finally these two terms cancel each other and here we are getting omega 1 into omega 2 is nothing but 1 by LC. So 1 by LC is equal to our omega naught square, right? So again the common thing, okay, omega 1 into omega 2 is omega naught square. Therefore F1 into F2 is equal to F naught square. So again Q can also be expressed as, that is Q can be given as Q is equal to omega naught into L by R, right? That is different forms of expressing Q. That's it. So omega naught is nothing but 1 by root of LC into L by R. So here the square root of L and this L cancel each other, and we will be having another square root of L. So finally here the value of Q is 1 by R into root of L by C. Right. So here comes the end of this derivation. If you have any doubt, let me know in the comment section. Thank you.